Hello, let's do one more example. And now we have a heat pump cycle. You can see this heat pump grabs heat from the left, which is the cold outside, QC, and then it releases heat QH into the warm house. So heat transfer happens from the low temperature TC to the high temperature TH. This will not happen unless you pay. So what we pay is W cycle, electricity. This house requires 6.33 times 10 to the fifth kilojoule per day. This is how much energy that is required if we want to maintain a house at 20 Celsius, which is a very comfortable temperature for us. And then we know the outside temperature is 0 Celsius. Okay, so now what is this 6.33 times 10 to the fifth kilojoule per day? Is it QC or is it QH? What is the direct parameter that keeps the house warm? That is QH. So don't be confused, this number is QH. And the house is maintained at 20 Celsius, so that is T hot. And the outside temperature is 0 Celsius, and that is T cold. So we have QH, TH, TC. What we're looking for is part 1, determine the minimum electricity consumption. And the second one is to look for the cost if the unit price of electricity is 8 cents per kilowatt hour. Kilowatt hour is a unit for energy, just like joules. It's a different unit for energy. Let's start from part 1. The minimum electricity consumption. When do we have the minimum energy consumption? That happens when you are at your best performance. When do you have your best performance? When your performance of coefficient gamma is equal to gamma max. And we can find gamma max pretty easily because we have the equation for it. The equation is TH over TH minus TC. We have both of them, and make sure you plug in temperatures in Kelvin. Solution for gamma max is 14.65 and doesn't have a unit because it is a ratio. And then let's recall what is the definition of gamma. Gamma is the coefficient of performance for a heating cycle. It's defined as purpose over cost. What is the purpose of a heating cycle? In other words, what is the direct parameter you want out of the cycle? QH. QH is the direct reason why your house is warm. So that's the purpose of the whole cycle. Divided by what do you pay? We pay electricity. So that's W cycle. Okay, let's take a look at this equation. Do we have QH? Yes, QH is given. Do we have a W cycle? No, we do not. We're actually looking for W cycle, the electricity consumption. Do we have gamma? Yes, because we know gamma is equal to gamma max, and we have gamma max. So from here, we can easily find electricity consumption, W cycle, and that is equal to QH over gamma max. Plug in the numbers. Solution for electricity consumption is 43,208 kilojoule per day. That's the electricity consumption per day, W cycle. So we're done with part 1. And then we go to part 2. What is part 2? Where part 2 is to look for the minimum cost per day. If the unit price for electricity is 8 cents per kilowatt hour, So from part one, we already found the amount of electricity you need. And next one in part two, we know the unit price. So we're looking for the total price. So total price can be easily found from unit price multiplied by quantity. Unit price is given, which is 8 cents per kilowatt hour. That is the unit price. And then what is the quantity of electricity we consume from part 1? 43,208 kilojoule per day. So you can see this calculation is pretty straightforward. The only thing that is a little bit challenging is the units. Okay, so what we're going to do first is to rewrite hour into seconds. So this equation becomes 3,600 seconds multiplied by 43,208 kilojoule per day. Okay, so now let's take a look. Watt multiplied by second. What is watt multiplied by second? That's joules. Watt multiplied by second is the unit joules, so we can rewrite this unit to joules. 3,600 kilojoules. So we keep kilo, and a watts multiplied by second becomes joules. Multiplied by 43,208 kilojoule per day. So now what do you notice? We can cancel kilojoule, and you can use the calculator. The solution is 0.96. And what is the unit that is left? Dollar per day. So now you can see if everything is perfect, the minimum cost for heating your house in wintertime is less than $1 per day. So that means your heating bill in wintertime should be about $30 per month. But does that ever happen? No. Why? Because reality is not as good as gamma max. You have to pay more, and that's because of irreversibility.